so in the last video you watched, you probably talked about atomic structure. The next thing we're going to talk about is isotopes. Okay, and isotopes is just a word for when an atom has a different number of neutrons. Okay, so remember in the last video on atomic structure we talked about how the differing number of protons determines which atom you're dealing with, right? So iron has 26 protons, cobalt has 27, that's what makes them different elements. Isotopes, okay, are when there are different numbers of neutrons, and that happens for a number of different reasons, but why isn't really necessary. It happens in nature. This is how we're describing it, okay? And so because of this, they have different numbers of neutrons. That means isotopes have different masses. That's the big takeaway here. They have different masses, or different mass numbers. Okay? And so the most common example that we have, that we use in science all the time, is carbon. Okay? And carbon comes in 3 varieties. Okay, there's 3 different types of carbon that are really prevalent throughout the universe. Okay, and those are, okay, they're called C12, C13, and C14. Okay, and the most common one is C12, and that's got 6 protons, right? This carbon has 6 protons. In fact, they all have 6 protons. Okay, but each one has a differing number of neutrons. So, C12 has 6 neutrons. Right? C13 would obviously then have 7 neutrons. And then C14 would have 8 neutrons. Okay? So that means their mass numbers would all be different, right? C12 is going to have a mass number of 12. Okay, because it has 6 protons and 6 neutrons. Remember, the mass number is the amount of protons plus the amount of neutrons because they have mass. Okay, C13 would have a mass number of 13, and then C14 would have a mass number of 14. Okay, and each one of these has a different percentage of availability on our planet. Okay, C12 is the most prevalent. It's like 96% or something of the carbon in the world is C12. And there's a little bit of C13, a little bit of C14, okay? So all of that, all right, is all put together, and the mass number you'd see on the periodic table, okay, for carbon is generally around 12.011111, and that means, right, there's more C12 on the planet on average than these other two, okay? So this one is the most prevalent. Remember, the mass number on the periodic table is a weighted average, right? The more of it there is, the closer it's going to be to that number. All right? The last thing that we need to talk about with isotopes is there is a certain way we write them. Okay, it's called isotope formation. Okay. And generally, what you do is, let's say you were kind of trying to write about their isotope. This is how you would write it out. So you've got C here. That's the element symbol for carbon. Okay, and what you'll then do is you're going to write the mass number up above it, kind of like this. So like 12, right, for C12. And then you would write the atomic number, or the element number, underneath it like this. Okay, and that means you've got carbon, 12, it's got 6 protons, 12 is its mass number. You can do the same thing for all of these. It's just a shorthand way of writing it out, an isotope. Okay? Isotopes do some important things. Later on, we might talk about a few of them. For instance, there are certain isotopes of uranium that are better for making nuclear fuel than other isotopes of uranium. Same thing with making atomic weapons. Uranium has a certain, or plutonium have two. There are certain isotopes that work better for those uses than others. It just depends on the amount of neutrons, the amount of protons, and how that all works. But that's a little bit more complicated than this video needs to be. So, isotopes, remember, it's when an atom has a different number of neutrons, okay, not protons. Protons change the element. It is just the number of neutrons. The weight changes.